A local blackout or a delayed shipping container can disrupt our access to food within hours. Yet, in some of the absolutely harshest environments on Earth, ancient societies engineered incredible systems that successfully fed millions. In recent years, minor logistical hiccups have easily emptied grocery aisles, proving that our immediate survival is almost entirely dependent on a highly exposed, incredibly complex web of distant global logistics. Add prolonged droughts and unpredictable extreme weather to that fragile supply chain, and relying exclusively on municipal water systems and commercial agriculture becomes a highly vulnerable position. Which raises a mechanical question. 4,000 years ago, how did populations cultivate thriving crops in high-altitude deserts without a single electrical pump or municipal pipe? They survived by mastering indigenous hydroengineering. When we extract those physics-based blueprints and power them with low-voltage automation, we create a resilient, modernized system that is designed to operate entirely and completely off the traditional grid. Shifting toward a system that operates on its own terms builds a physical buffer between the individual and the instability of the wider world. This photograph shows a Zuni Waffle Garden, a dry farming technique engineered by the Ashui people to maximize moisture retention in high-altitude deserts. Notice the inverted, recessed squares. These sunken grids trap limited rainfall, while mounded clay walls cast shadows that drastically lower evaporation rates. Across North Africa and ancient China, populations utilized a different subterranean technique, Olla pots. These are unglazed, wide-bellied terracotta vessels buried deep in the dirt right next to crop roots. Because the clay is microporous, water seeps through the walls via capillary action. Soil moisture tension pulls the water outward only when the dirt is dry. Roots wrap directly around the buried pot and drink on demand. This results in the reason people abandon their backyard gardens is the sheer friction of daily maintenance and the physical exhaustion required to keep plants alive through the summer heat. We are seeing a design trend known as lemonading, the practice of taking degraded, broken spaces and converting them into fuss-free, ecologically restorative environments. This schematic illustrates how we apply Solarpunk automation to those ancient frameworks. We capture roof runoff into a gravity-fed cistern, route it through a low-voltage solar timing valve, and pipe it directly into a buried subsurface network of Olla pots. This layout replaces thirsty, manicured lawns with wilder, dense foliage that supports local pollinators and yields high volumes of food without municipal water. By merging passive historical infrastructure with simple off-grid smart technology, the exhausting chore of manual farming becomes a self-regulating, zero-evaporation ecosystem. The predictability of a self-regulating ecosystem provides a stabilizing influence that counters the volatility of external events. The Stoic philosophers practiced the dichotomy of control. They recognized that external variables, like global supply chain shocks, inflation, or severe weather patterns, are entirely outside our influence. However, our immediate physical actions remain fully within our command. Within the garden, the focus shifts from abstract digital stress to the concrete, immediate requirements of the soil. The physical labor required to shape the earth and plant the seeds functions as a green gem. It operates as a moving meditation that anchors attention in the present moment and builds physical resilience through deliberate effort. Modern therapeutic garden designs intentionally integrate pause points, dedicated physical spaces, like a simple bench near a water feature, built into the layout purely for you to rest, observe the automated system at work, and decompress. Cultivating a self-sufficient space is about constructing an inner citadel. When you insulate your immediate food supply and regulate your nervous system through focused labor, you build a state of mind that remains steady against the friction of the 21st century. To begin securing your own soil and focus, click the video on your screen right now. I'll walk you through the exact step-by-step process of building a self-watering Zuni waffle grid in your own backyard. We've established our baseline. By digging this Zuni waffle garden, we built earthen walls that block the wind and shield the soil surface. We've secured the architecture, but architecture alone cannot survive historic droughts if we rely on municipal water sprayed from above. When you spray water onto sun-baked dirt, most of it evaporates right back into the atmosphere before it ever sinks in. The engineering problem is simple but critical. How do we deliver water directly to the plant roots, completely bypassing that hot, exposed topsoil. Surface-level wind protection falls apart if our subsurface irrigation is bleeding moisture into the sky. The answer looks like this. Unfired clay can literally sweat moisture through its microscopic pores directly into dry dirt. This is an Olla pod. Indigenous cultures across some of the harshest, most arid landscapes on Earth have buried these unglazed, wide-bellied vessels next to their crops for over 4,000 years. Looking at this diagram, you can see the physics at work. It relies on capillary action. Soil moisture tension actually pulls water through the microporous clay walls. But the brilliant part is the feedback loop. Once the surrounding earth reaches saturation, the physical tension drops and shuts the system down. It only waters when the soil is dry. The plants figure this out quickly. Their root networks naturally detect that exact moisture gradient and wrap themselves directly around the clay vessel, sipping exactly what they need right on demand. We are going to take that exact ancient mechanism and engineer a completely enclosed, modernized version of it, and we can do it for under $5. Shifting away from top-down sprinklers to subsurface capillary action eliminates evaporative waste entirely. All you need to construct this are 2 identical, inexpensive terracotta planting pots and a single tube of silicone caulk. The absolute most critical detail here is that the pots must be raw, unglazed terracotta. If there is a shiny glaze on the outside, the micropores are permanently sealed and the physics will fail. First, take a stopper, plug the bottom drainage hole of one pot, and seal it completely watertight with the silicone. Next, apply a thick, continuous bead of caulk to the top rim of that bottom pot. Take your second pot and stack it upside down right on top. You've now formed an enclosed subterranean reservoir. Finally, we buried this newly joined structure securely in the center of our Zuni Waffle grid. We pack the dirt down so that only the top drainage hole remains exposed above the soil line. By gluing 2 standard pots together, we've drastically increased our underground holding capacity while keeping the cost to a fraction of a commercial, custom-made Olla. But there's a lingering inefficiency in the historical method. Filling these pots requires someone to constantly walk out into the field and haul water by hand to refill each reservoir. We can eliminate that chore with a modern Solarpunk upgrade. We take a 1/4-inch polyethylene drip line and run it directly into the exposed top hole of our buried Olla. It is vital to cap that hole tightly around the inserted tube. A tight seal stops the water from evaporating out the top, and it blocks mosquitoes from using your reservoir as a breeding ground. Now look at the complete energy loop. We capture rainwater in an elevated tank. That water flows downward via gravity through our drip tubes, regulated entirely by a low-voltage solar-powered timing valve. This specific combination, the unglazed clay physics of the ancient world, powered by modern off-grid gravity tubes, gives us an agricultural engine with 0 daily maintenance and 0 wasted water. Engineering water is 1/2 of survival. The other half is the mental framework required to face a climate that no longer follows the rules we grew up with. In his Meditations, Marcus Aurelius documented the need to separate external chaos from internal action. We don't control the timing of the next heat wave, but we control the thickness of the earthen walls and the volume of the subsurface reservoirs. Stoics called this amor fati. In the garden, we treat the drought as a design constraint rather than a tragedy. The lack of water becomes the reason the system exists. Tending this green gem turns the anxiety of an uncertain harvest into a meditative focus on maintenance. Scientific research on nature-based interventions shows this shift produces a measurable rise in life satisfaction, often exceeding 7 points on a standard happiness scale. Food security begins with a full cistern and ends with the quiet confidence of knowing exactly how your sanctuary functions when the grid goes dark. Successfully replicating this hybrid system requires exact component lists, the correct soil to clay ratios, and the precise layout specifications. To help you get started, we've put together a free complete Agrarian ARC blueprint that outlines every step. Click the link located in the video description or the pinned comment to claim your free blueprint right now. Taking that action is the first concrete step in transitioning from passive worry into actively building your own personal off-grid sanctuary.